So welcome back. In this second part of our solving rational equations, we're going to look at some weighted average problems. So each one of these that I'm going to show you are a little bit different, but you'll start to see the familiarity of the idea of setting these equations up. Now, the ones that we're going to look specifically at today are chemistry or mixture problems, distance problems, and work problems. Now, what are weighted averages? So they're a way to find the mean of something when each part or each piece doesn't have an equal weight to it. So some elements in the problem are going to be weighted a little bit more than the others. So when you're looking at like work type problems, if you're looking at maybe yard work and you're looking at a boy and a girl, and a boy might be able to do the work a little bit faster than a girl or vice versa. And so they're not pulling together the equal amount of work. So we're going to be able to figure out how fast they can do those jobs together depending on the weight of the work that we are going to accomplish. All right, so for our first example, it's a chemistry problem, and it's talking about adding a brine. Now, if you don't know what a brine is, sometimes your parents or grandparents will put a brine on a turkey before they make their Thanksgiving dinner. So brine is like a salt and herb and water mixture that you can put on top of meat to make it a little bit more flavorful, make it a little bit more tender. All right, so this problem is about Aaron, and he's going to add an 80% brine, which is the salt and water solution, to 16 ounces of solution that is already 10% brine. It asks how much of the solution should be added to create a solution that is 50%. All right, so what I did was I started out with a table to help us organize our information. So we're going to look at the amount of brine that's put into the original, what we're going to add, and what our new brine is going to have. So in the original, it said the original was 16 ounces, and the original solution was 10% brine. So the original was 10% of 16 ounces. All right, so our total number of ounces at this point were 16. So we're going to add 80% brine. So that's, you can see now it's a different weight to it. But what we're going to add is 80% of, we're not sure how much of the solution needs to be added. All right, so that's going to give us, when we work this out, the new solution is going to have 10% of the original plus 80% of the new. How much we need to add is what our unknown is. So our new is going to be 16. This is the solution plus x. All right, so how do we work this problem? So this problem is going to be that we're looking for the percent of the brine solution. To find this percent, it's going to be equal to the amount of brine divided by the total solution. So you can see where the rational part exists. All right, so we want the percent of brine solution to be 50%. So that's really 50 out of 100. We're going to set that equal to the amount of brine, and the amount of brine in the new solution is going to be 10% of 16 plus 80% of x, divided by the total solution, and the total solution is 16 plus x. Now, we're back to solving these rational expressions. Now, since we only have two, I could still multiply both sides by the LCD, or I can do a quick cross multiplication process like a proportion, because that's what we have. So here the math is going to be 50 times the quantity of 16 plus x is equal to 100 times the quantity. Now, if I do a little bit of this in my head, 10% of 16 is going to be 1.6, and then I'll have plus 0.80x. x. All right, so let's do our distribution here. So our distribution is going to be 50 times 16, which is 800, plus 50x is equal to, I'm going to multiply that by 100, so that's going to give me 160 plus 80x. So since I'm running out of room, I'm going to come up here real quick. I'll subtract 160, that's going to give me 640 is equal to 30x. So the amount of solution that I should have if I divide both sides by 30 is going to be 21 1/3 ounces. That's what's going to give us an 80% brine solution. So Aaron needs 21 1/3 ounce solution. And that's going to achieve his 50%. So that is your mixture or your chemistry type problem. All right, so let's look at the second example. The second example is about swimming. And it says Lilia swims for 5 hours in a stream that has a current of 1 mile per hour. She leaves her dock and swims upstream for 2 miles and then swims back to her dock. So that means she's going to swim 2 miles back. What is her swimming speed in still water? All right, so when we're looking at the current being 1 mile per hour, that's going to help her in one direction, but in the other, that's going to hurt her. So if we do a quick distance ratio, if distance is equal to rate times time, then our time is going to be the distance divided by r. So we're going to just manipulate this distance formula here. So we want to come up with a ratio for her time with her currents. Now, we're going to take that distance, which is 2 miles, and we're going to divide it by her time with current. So her time with current is going to be whatever her rate is, but when she's going with the current, that's going to go against her. So that's going to be to r plus 1. When she go, I'm sorry, that's not going to go, that's going to help her. So that's going to give her her rates plus another 1 mile per hour. That's going to help her, not hurt her. It's going to hurt her the other way. When she goes with her time against the current, she still has to go 2 miles, but this time it is going to hurt her. It's whatever her rate is minus that 1 mile per hour. And then we know that she swims for a total of 5 hours, so that's going to have to equal 5. So we're looking for what her rate is in the still water. So once we take out the aspect of the actual current helping her or hurting her. So we're just going to simply add those together. So it takes 2 over r plus 1 plus 2 over r minus 1 to get a time, because I use the time for each one of those, of 5 hours. So if I look at this, I need an LCD, and my LCD is going to be r plus 1 times r minus 1. So just as I've done in previous problems, I'm going to multiply both sides of my equation by the LCD. And you're going to see that it's going to cancel my denominators once I work through the math. Okay, so I can do a quick simplify, nothing's going to simplify in the last, so I'm going to simplify 2r minus 2 plus 2r plus 2 is equal to, now I'm going to have to simplify this first. That'll give me r squared minus 1 because that's the difference of squares. And then I'll distribute that 5 to it, and that's going to give me 5r squared minus 5. So now I'm going to have to simplify this, and my 2's are going to cancel. So I'm going to have 4r here, and I'm just going to go ahead and take that to the other side right now. That'll give me 5r squared minus 4r minus 5. So now I need to solve this. Now we can try factoring. You could try the slip and slide method, but neither are going to work because they're not going to factor. So therefore, to solve this quadratic equation, I'm going to utilize quadratic formula. So my quadratic formula, x, or in this case, we're not solving for x, we're solving for r is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is going to be 10. Now, when we go ahead and finish solving this, I'm going to get two answers. However, one of those answers is going to be negative. So I'm going to throw that answer out, and I will find that the rate that she swims in still water would be 1.477 miles per hour. Of course, that changes as she moves with the current or without the current. That's going to change. So in still water, her rate is 1.477. So you can see that that is our second example with a distance problem. All right, so I'm going to move to our last word problem, and this is actually a work problem, and we're looking at two people that have a different work weight to it. So we're looking at, I'm going to probably mess this up, Wu Yai and Weema. I'm going to just hope that's as close as I can be. Mow lawns together. The first person working alone could complete a particular job in 4.5 hours. So that's only one job in 4.5 hours. Uema could complete it alone in 3.7 hours. So she's a little bit faster. So the first person is one job for 4.5. The second is one for 3.7. How long does it take to complete the job when they work together? All right, so let's look at my first person. Their work is one job for 4.5. My second person is the same job for 3.7. Now, what we want to do is figure out the time they could do it if they work together. So I'm going to add them together, working together. So it's still one job, but I'm missing the rate at which they can do it together. All right, so now it becomes just a simple rational problem. And if I look at my LCD to both sides of this, 4.5 times 3.7 is 16.65x. So I'm going to go ahead and multiply both sides of my equation by my LCD. And when I simplify that out, 16.65 divided by 4.5 obviously is going to give me the opposite. And this is going to give me 4.5x. And in my last, my x's are going to cancel, leaving me with 16.65. So I'm going to go ahead and add these two pieces together. That's going to give me 8.2x is equal to 16.65. And when I divide both sides by 8.2, I get roughly that if they do the work together, it will take them about 2.03 hours. So you can see the first person alone took 4.5. The second person alone took 3.7. So that's not equal work efforts. So when I averaged and I put them together, averaging them out together, they can get the job done in about 2.03 hours. All right, so I'm going to add our last problem from this lesson. This last problem is an inequality as opposed to all of the equations that we've done previously. So this inequality, I'm going to find my LCD. So I'm going to treat it kind of at first like it's an equation to go ahead and solve. But with inequalities, you'll remember that we have restrictions. And with rational expressions, we have restrictions. So we're going to have to take all of those restrictions into account when we solve. So I'm first going to find my LCD in this problem, and my LCD is going to be 9K. So just like I did in the past, I'm going to go ahead and multiply each term because I'm multiplying everything on the left and everything on the right by 9K. So that's going to give me 9K times 1. 9K times 2 is less than 9K times 2. Okay, so I will simplify. 9k divided by 3k is simply going to be 3 plus 2 is less than 6k. So 3 plus 2 is less than 5 is less than 6k. I'll go ahead and solve that, and I'll get that k is greater than 5/6. Now, I need to take into consideration what is not allowed. So I want to first look at any excluded values in this problem. So my excluded values would be where do any denominators equal 0? So if I look here, 3k would be equal to 0 at 0. 9k is equal to 0 at 0, and 3 can't be 0. So my places that would be excluded is that k cannot equal 0. All right, so once I've solved and I found my excluded values, I'm going to put all of these on a table, on a number line. So here I have 0 on a number line. I know that 1 is here, so 5/6 is probably going to fall about right here. Now, because 5/6 is an answer, I'm going to go ahead and give myself kind of a little boundary vertical line here. And because I know something important is happening at 0, because 0 doesn't exist in the denominators, I'm going to put a vertical line here. Then I'm going to pick a value on each piece of these, and I'm going to test it. So I'm going to test this piece, I'm going to test this piece, and then I'm going to test this piece last. All right, so by testing it, I'm going to plug it back into the original. So what is less than 0? Well, that's -1. So that just makes it easy if I plug in there. So if I test -1, that's going to give me -1/3 minus 2/9 is less than 2/3. So that gives me -3, what do I have here? Real quick here. That gives me -3/9 minus 2/9 is -5/9. And that is indeed less than 2/3. So this piece is going to be part of my solution set. All right, now I need to pick a piece in between. So I'm going to just maybe pick 1/3 here, and I'm going to throw 1/3 into this inequality. So 1 divided by 3 times 1/3 is just 1, plus 2 divided by 9 times 1/3. 9 times 1/3 is 3, so that's going to be 2/3. And I'm testing to see if that's less than 2/3, and I can already see that it's not. So that is nothing existing in between. So my last part would be to check a value to the right of this. So I'm going to go ahead and check 1. So if I throw a 1 up here, that's going to give me 1/3 plus 2/9. So that's going to give me 1/3 is 3/9. So that'll give me 5/9 is less than 2/3. And if I make that a 4/9, multiply the top and the bottom, that's actually a 6/9. That is indeed true. So that means that this is going to be a solution in my set. So I am going to have a complex solution where I don't have anything between 0 and 5/6, but everything to the left of 0 and everything to the right of 5/6 is going to be a solution. So I will mark it as an OR. K is less than 0 or K is greater than 5/6. That's going to be my solution for this rational inequality. All right, if you have any questions, please let me know. I'm gonna give you some more problems today to practice up on these equations and inequalities. I hope you have a wonderful day.